Next, we're going to take a look at what to do when we have non-unit circle values. Basically, it ends up being SOHCAHTOA. If you drop in the right triangle, instead of sine simply being y, it would be y over r. And you would fill in the values for the rest of the 6 trig functions. I'm sure you'll catch on very quickly as we run through our examples. Our essential question today is evaluating trig functions for points not on the unit circle. A little hint off in the right-hand column, you can tell it's not a unit circle point if you don't have fractions. So first of all, we'll figure out which quadrant we're in. Of course, -12, -5 would land us in the 3rd quadrant, approximately there. Labeling the sides we know. And then we'll have to use Pythagorean theorem to solve for the side that we don't. Once we square it, they'll become positive anyway, so I'm just going to drop the negatives. 12 squared plus 5 squared equals our radius squared. 12 squared is 144 plus 25 gives us 169, and the square root of that is 13. Once we know all 3 sides, we can easily generate those 6 trig functions. Sine is y, or opposite, over r, or hypotenuse. Cosine will be x over hypotenuse. Tangent is opposite over adjacent, which simplifies to a positive 5/12. And our reciprocal functions. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. We've already done a lot of work with this. Now we're going to set up a little chart. Of course, in the first quadrant, everything is positive. In the second quadrant, our cosine is negative. Sine is positive, so the ratio or tangent would be negative. In the third quadrant, cosine and sine are both negative, so the ratio of those or tangent would be positive. And in the fourth quadrant, we have a positive cosine, a negative sine, and the ratio or tangent would be negative. We're going to use this chart to determine which quadrant theta is in if all we know is the sign, positive or negative, of different trig functions. First, I'm going to generate that little sine table that we had on the last one. Sine and cosine are both positive, so is tangent. Cosine's negative, sine's positive, tangent's negative. Both cosine and sine are negative, so tangent is positive. And cosine's positive, sine is negative, and tangent is negative. Our first question is if sine and cosine are both greater than 0 or positive, that would have to occur in the first quadrant. Second question, cosecant is negative. We have to think about the fact that cosecant is the reciprocal of sine. So we're saying sine is negative, which occurs in the third and fourth quadrants, and cosine is also negative. Sine and cosine are both negative in the third quadrant. Part C, sine is negative, so we're in the third or fourth quadrant, and tangent is positive. That occurs in the third quadrant. And our last one, secant is less than 0 or negative. Secant is the reciprocal of cosine. That occurs in the second or third quadrant. And cotangent is negative. Cotangent's the reciprocal of tangent. So cosine and tangent are both negative in the second quadrant. Knowing our cosine value and knowing we're in the third quadrant, we're going to determine what the other 5 trig functions are. Cosine is adjacent over hypotenuse. If you are familiar with some Pythagorean triples, and it's helpful if you are, 3, 4, 5 forms a right triangle. Of course, if you're not familiar with that, you use Pythagorean theorem. In the third quadrant, of course, that y value would be negative, so sine is negative 3/5. We already know our cosine, so we'll figure out tangent, which is opposite over adjacent, and of course those negatives cancel again. Cosecant is the reciprocal of sine, so we have a negative 5/3. Secant is the reciprocal of cosine, so we have negative 5/4. And cotangent is the reciprocal of tangent, so we have 4/3. Similar question, we're given the cosecant, so we can find the reciprocal of cosecant, which is sine. We are also told that cotangent is less than 0, which means tangent is also negative. Sine is positive, and tangent is negative in the second quadrant. Sine is opposite over hypotenuse. This is not a Pythagorean triple, so we'll have to set up Pythagorean theorem. We're solving for our x value in this one. So we have 16 minus 1 is 15. Our x value is the square root of 15. In the second quadrant, that means it is negative square root of 15. Cosine then would be negative root 15 over the hypotenuse. Tangent is opposite over adjacent. Rationalizing, we'll move that root 15 up to the numerator and drop it in the denominator. We already know cosecant. Secant is the reciprocal of cosine, which is negative 4 over root 15. Rationalizing this one as well, moving that root 15 up to the numerator and dropping it in the denominator. Finally, cotangent is the reciprocal of tangent, so we'll flip that unrationalized version so we can get a rationalized version of cotangent right away. Please attempt your U-Try questions. Come to class with any questions that you have on this material.